Welcome, friends. In today's lecture, we continue the first lecture wherein we discussed the force exerted by a jet on a stationary flat plate held normally, and also the force exerted by a jet on an inclined flat plate. So, these two cases we solved in the first lecture. In today's lecture, we will complete the remaining three cases of a stationary curved plate or stationary vane. So these three cases in this we will take it up. With that, we will be completing all the cases related to the jet striking a stationary plate or vane with normal or inclined or curved, whatever it is. So let us straight away go into the three cases of the continuation part. So case 3. What is case 3? Force exerted by a jet on a stationary curved plate, or the same thing is called wave. The plate is symmetrical, plate is held symmetrical, and jet strikes at the center of the plate. So this is the question. So now let me start the case by drawing the, you see how I have drawn, right? So this is a curved plate or vane. It is fixed, right? Now the jet striking it. So always now jet striking at the center I told. So better draw the central line first. This is the first thing you need to do it. Then after doing it, now you put the jet striking. This is the pipe. This is the nozzle portion from where the jet is emanating. So this is how the jet strikes at the center and leaves like this. This is how the jet strikes at the center and leaves like this. This is how it happens. So if I take V is the initial velocity, D is the diameter of jet. After striking it, it leaves like this. It goes like this, tangential to the tip of the vane. So this is how it goes. Suppose that means instead of going like this, if I draw a tangent right? If I draw a tangent at the tips, if you can see, these are nothing but the tangents drawn, tangent drawn. So this angle is theta, this angle is also theta. If both angles are same, then we call it as symmetrical. If suppose these angles are different, then we call it as unsymmetrical. So kindly remember that symmetrical means both the angles same. So that means after the jet going like this, striking, and it is leaving like this. So how much angle it is basically moving? It is 180 minus theta. This is what we call it as deflection angle. Deflection angle means the jet is deflected through an angle of, because if it goes straight actually 180, so it is basically going actually how much it is making. So this is how much it is deflected, that is 180 minus theta. So here the only the basic thing that you should remember is initial velocity is fine. It is v, but final velocity is not actually in the x direction. If you see, the jet is deflected through an angle of 180 minus theta. So that is why actually here at the outer tips, if you can see, naturally it will be the velocity will be having two components. If suppose this is the tip actually here, it if it is v, it is having both the components in both the directions. So similarly, if I see here, the velocity will be having its components in the x direction and in the y direction. If I calculate what is this angle actually, theta, so therefore Vx is equal to, if you see what is the component in this direction, is equal to V cos theta. What is the component in the vertical direction here? It is V sin theta. So this is the only difference from the previous case. Now if I write it, consider a jet of diameter t strikes a vane. Vane, which type of vane? A symmetrical vane. At its center, the jet, after striking the vane, leaves tangentially at outer tips. Right? Now, applying impulse momentum equation, applying impulse momentum equation, you know it actually, the force is equal to mass per second into initial velocity minus final velocity. Whatever direction the force you are taking, the initial velocity and final velocity should be taken in the same direction. So now let us consider, because now consider, if I consider x direction better. So what are the items first? Mass per second. Mass per second is what? Rho q. It is nothing but rho av. Initial velocity, the whole initial velocity is in the x direction, it is v. What is final velocity? Final velocity in x direction, please note this, is equal to V cos theta, because this is how it goes. V. So I want this component. This is theta, V cos theta. Right? This is what you should understand. Therefore, Fx is equal to rho AV into V minus of. Again, see, V is in which direction? The V is V. If you take it, this is how V is. Positive direction of x-axis. How the V cos theta is in the negative direction. So naturally, what will happen? It is minus V cos theta. Right? What this minus indicates? It is acting in the opposite direction, not in the positive direction of x-axis. Therefore, rho A V square into 1 plus cos theta. That's all. Fx is equal to. Right? This is one. First one is closed actually. So now basically, if I take what is y direction, if I take, yeah, in y direction, let us take that also in y direction. Right? Mass per second does not change. Mass per second is always rho q. It is equal to rho av, right? Initial velocity. Initial velocity, which direction I should take? In y direction. The whole initial velocity is in the x direction. So in y direction, the velocity is equal to 0. Therefore, final velocity is equal to V sin theta. V sin theta is acting which direction? Upward direction. Therefore, Fy is equal to mass per second rho AV into 0 minus V sin theta. So it is minus rho AV square sin theta. What do you mean by minus value? The minus in, we assumed that the direction of force is upwards. The minus sign indicates Fy is downwards. That's all. So once again concluded this actually, what is Fx is equal to rho A V square into 1 plus cos theta. Whereas what is Fy is equal to rho A V square into basically minus rho A V square into sin theta. Please don't forget this minus. That's why Fx will act like this, Fy will act like this. This is how Fx acts, this is how Fy acts. So this case is completed. Now let us go to case 4. What is case 4? Force exerted by a jet on symmetrical vane, jet striking at one end. Previous case is jet strikes at the center. Now jet is striking where? Actually jet is striking at one end. So how we look at that also we will see. First I will draw that actually. So this is, this is the curved vane. You can draw in any fashion. The only thing is, but you should draw. I will draw neatly, a little bit better. Right? So this is the curved way. Again, fixed. Always I draw the center line. Irrespective of whether it strikes or not, center line is always required for me because that shows x direction. This is y direction. So now what is happening? Jet is striking here. Jet is striking here, and jet is leaving here tangentially. If I draw extend it, it is a tangent. Similarly, if I extend it, it is a tangent. As it is symmetrical, this angle is always theta. Both angles should be same. That is why it is called as symmetrical. Right? It is how it strikes, and this is how it leaves. This is how you should draw the figure. Right? This is how the jet is striking at a velocity v and jet is leaving at a velocity v. And what is this? The tangent. This is what you should remember. Now, as usual, consider a jet of dia d strikes a symmetrical wave which is stationary at one end. The tangent makes an angle theta with x direction. Applying impulse momentum equation, force is equal to mass per second into initial velocity minus final velocity. Remember, force in whichever direction you are calculating, these velocities also should be in the same direction. Now let us go straight into the problem. So x direction, I will take it. Mass per second, it is again rho a v. Straight. That much mass only is striking. Then initial velocity. Which direction we have to take? I have already defined at the top, x direction. So what will be the initial velocity? That we call it as v1x. v1x is equal to how much? This is how it strikes. This is v. So what it will be? V cos theta. Right? V cos theta. Final velocity in which direction again? X direction. It is v2x. How it is leaving actually? This is leaving like this. This is v. So I want in this direction. It is again v cos theta. What is the difference? This is the in this direction. This is actually in this direction. So what can I write? This is minus v cos theta. Why minus? Because it direction is different. Therefore, what is Fx is equal to rho AV into mass per second. What is V cos theta? Minus of minus V cos theta. So it is rho A V square into this is again V cos theta plus V cos theta, 2 V cos theta, 2 rho A V square cos theta. So finally, what is Fx is equal to 2 rho A V square cos theta. So this is the first thing. Now if I take in y direction, Y direction. What is mass per second again? Mass does not change. So it is rho AV. Then what is initial velocity? Initial velocity in y direction. Suppose now actually the jet is striking, it is, I call it as v1y. v1y is equal to. So how the jet is striking, this is how it is striking. So this is v. What is this direction? If you take it actually, this is v, it is v sine theta. So v sine theta. Then final velocity, it is v2 y. It is equal to, suppose the jet is leaving like this. So what is the again, this is again v sine theta. So this is v cos theta. This is v cos theta. This is v sine theta. These angles are theta. Right? So it is again v sine theta. So now if I put it Fy is equal to rho AV into v sine theta. Both are acting upwards only. Minus v sine theta. So naturally it is equal to 0. So final cases, both the cases are over. So this completes to me the fourth case. What is the last case? Case 5. Case 5 is nothing but it is only a small change from case 4. That is a force exerted by a jet on a on an unsymmetrical. That is the only difference. Unsymmetrical. Previous two cases are symmetrical. Unsymmetrical vein, jet striking at one end. Again, of course, unsymmetrical. Here you can put stationary. This is the thing. So that is the only difference. Beyond that, nothing. So again, I will try to draw the figure. So this is fixed, fixed. Now the center line always for me most important thing is the center line. First you should draw. So this is X, this goes for Y. This right? What is unsymmetrical means now while putting it actually you remember that it should be tangential, right? That means if you extend this, it is theta. So here this is V. Similarly, it leaves like this. This angle is different. Previously, both these two are same. Now this is theta, incoming jet is theta, why outgoing jet is at phi. So that's why it is called as unsymmetrical, right? These two are different. That's why it is theta, phi, two things. In all previous cases, it is symmetrical means both are same and it is leaving with v. Right? Again, the like previous case, you can directly write it. I will straight away go into the problems, right? How to solve the issue. X direction I will take. I'm not explaining all the things straight. I am going. So what is mass per second is equal to rho Q, which is equal to rho AV. What is initial velocity? This is important. So jet is striking like this. It is V. I want in x direction. This angle is theta. So it is V cos theta. Right? What is final velocity? Jet is leaving like this. It is V. This is what we want. Again, this angle is phi. So it is V cos phi. But only thing is direction is different. So that is why minus V cos phi. In previous case, both are same, but now the difference is theta and phi unsymmetrical. So therefore, applying impulse momentum equation, applying impulse momentum equation, force is equal to mass per second into initial velocity minus final again I am repeating force in whichever direction you are taking, naturally the velocities also should be in the same direction. Suppose now what direction we are taking, x direction, so it should be what, fx is equal to mass is rho a v into what is initial velocity, it is v cos theta, in which direction, x direction, minus of minus what is final velocity in x direction, minus v cos phi. Why minus? It is in the opposite direction. So therefore, it is rho a v square into cos theta plus cos phi. This is the first case. Now let us go into the second case. Second case is what? Y direction. Mass per second is how much? Again, same. It is rho AV, right? Then what is initial velocity? Now, this is how it strikes. This is V. So this is V cos theta because this angle is theta. This is how much? V sin theta. What is final velocity? The correct meaning of it is initial velocity means the velocity with which the jet strikes. What is final velocity? The velocity with which the jet leaves the vane. So now again I will tell you how this is leaving, this is how it is leaving. So this angle is phi. So now this we have written as V cos phi. So naturally this is V sin phi. So V sin phi, right? Now, therefore, Fy is equal to, right, rho a v into V sin theta minus V sin phi. Therefore, rho a v square into sin theta minus sin phi. So this is Fy. So Fx is equal to, finally conclude, Fx is equal to rho a v square into cos theta plus cos phi unsymmetrical. Fy is equal to rho a v square into sin theta minus sin phi. So this completes five cases of completes the five cases of stationary plate or wave. So in all the five cases, what we found, we calculated force. This is the thing. So if figures, if you remember in mind, everything will settle very fast actually. So I will stop my lecture at this point, and then we will go into the next lecture wherein the condition, next condition has to be stationary. We have completed. So what is remaining for us? The remaining for us is basically then actually how to go about moving. So, friends, I have completed all the five cases related to the force exerted by a jet on a stationary plate or vane.
Like, share, and subscribe. Hit the bell icon for more updates.